So this question's a little bit longer because there are four parts to it, part A, B, and C. And I recommend that you just kind of fast forward and find the parts, if any, that you need to review. The first one, all of them do say solve each equation by after rewriting it in a simpler equivalent equation. So let's take a look at this first one. One of the things I can do to simplify this equation is I can certainly apply the distributive property. If I do that, on the left-hand side, this 3 is going to be distributed across the subtraction problem. So each one of these terms is going to get a factor of 3. So this is going to become 3 times 3x, which is 9x, and 3 times negative 6, which is minus 18. And then we have the plus 5. And on the other side, we have 5x minus 29. I can simplify this again further by looking at the left-hand side and rewriting it as 9x minus 13 equals 5x minus 29. I think I'll apply now the subtraction property of equality. If you have equal things and you subtract the same thing from both sides, you get equal things. So I'm taking away 5x's from each side. Over on the left-hand side, that leaves me with 4x and then still the negative 13. On the right hand side, I now just have the negative 29. I'm going to add negative 13 to both sides. I'm sorry, positive 13. Again, if you have equal things and you add equal things, you get equal things. So I'm adding 13 to both sides. This now will become 4x is equal to, I think this is going to be negative 16. And then finally, if I divide both sides by 4, right, if you have equal things and you divide by a non-zero equal things, you get equal things. On the left-hand side, you can see there's a giant 1. I'm left with an x. And on the right-hand side, negative 16 divided by 4 is negative 4. So x is negative 4. And as great as that looks, I'm always a little reluctant to say that's the answer until I see that it does what it's supposed to do. It's supposed to make the left and the right hand side the same. So I'm going to just go ahead and grab my calculator here, and I'm just going to enter 3, and then I'll do open parentheses 3 times. Now I'm going to put parentheses for this negative 4. So that's 3 times the quantity 3 times negative 4. And then I need to subtract 6 from that, close the parentheses, and then add 5. And when I do that, I get the number negative 49 over on the left-hand side. On the right-hand side, I have 5 times this negative 4. That'll work just fine. And then minus 29. And when I do that, I also get negative 49. So I know that when x is negative 4, both the left and the right hand side of this equation become negative 49. So it does indeed do what it purports to do. It makes those two quantities the same. It makes them equal to each other. So x has to be negative 4. Let's move on to part B. As I look at part B, the thing I'm thinking is fraction busters, and I'm going to multiply both sides of this by a value that will destroy all the fractions. And if I look at it, my common denominator, 3 and 10, there's no common factor. So I'm just going to multiply both sides by 30. And I'm going to choose to write it as 30 over 1 so that I can show you a little bit more slowly what happens. So over on the left-hand side, in the numerator, this becomes 30 times the quantity of x minus 5, and that's all divided by 3. Over on the right-hand side, this becomes a 3x, again, times a 30, and then all over a 10. So if I look at it, there's some giant ones that are lurking here. On the left-hand side, this is certainly, on the left-hand side, this is certainly a 3 times a 10 times an x minus 5. And I've just done this just so I can see very clearly that 30 over 3 really is 10. And over on the right hand side, there's the 3x, and then I've got the 3 times 10. And when I look at this, because these are all factors, I can see I have this giant 1 here. Again, it's important that they're factors, not terms. So on my left-hand side, this becomes 10x minus 50, and over on the right-hand side, it becomes simply 9x. So I'm going to subtract 9x from both sides. And when I do that, it's always a danger. But over on the left-hand side, I'm left with 0. There's nothing over there on that side. On the right-hand side, I have just an x minus 50. And then I'm going to add 50 to each side. And when I do that, I get that x is the number 50. And again, it's very much worth it to check and make sure that 50 does make both the left and right hand side the same. So again, here's my calculator, clear it all. I think x is 50. So in the numerator, I'm going to enter 50 minus 5, close the parentheses, and divide that by 3. And you can see that I get 15. On the other side, I'm going to go 3 times 50 and then divide that by 10. And you can see, wait. Oh, it's 50, not 15. 3 times 50 is what x is. And divide that by 10. Yeah, 3 times x divided by 10. And I also get 15. So because these are both the same, right, it made them both 15. This is definitely the answer, right? This checks quite nicely. Question C has a hint. You can replace 9 with 3 to the second power. So if I'm looking at this, on the one hand, I have 3 raised to the, 3 raised to the 4x minus 1 power. On the other side, I'm going to replace this 9 with 3 squared to the x power. When we have a power raised to a power, this right-hand side can be simplified further as 3 to the 2x. And over here I've got 3 to the 4x minus 1. Now, the only way that this can be true, that the left and the right-hand side are equal to each other, is if this value in the exponent on the left and the value in the exponent on the right are the same. Those two things have to be the same in order for these to truly be equal to each other, since the bases are the same. So to simplify this, we can set these equal to each other. And I guess I'll subtract 4x from both sides. You know what? Let me write that step down. So I'll subtract a 4x from each side. I can do this because these things are equal, and I'm taking away 4x's from each side. That gives me -1 equals -2x, and now I can divide both sides by -2. Over on the right-hand side, that -2 over -2 is a giant 1, so I'm left with x. And then -1 divided by -2 is +1/2. So x should be the number 1/2. And if I plug a 1/2 in there, it should make both the left and the right-hand side true of the original equation. So I want to try that. So I'm going to take a base of 3 and I'm going to raise it to the power of 4 times 1/2. I'll use a decimal for that, 0.5, and then -1. So when I do that, I get the number 3 on the left-hand side. On the right-hand side, I have 9. I'm going to raise that to the 0.5 power, to the 1/2 power. And when I do that, I also get 3. So yeah, when x is 3, both of those sides, both the left and the right-hand side, become 3. So when x is 1/2. So x is 1/2, and it forces the left and right to both equal 3. So x is 1/2 is my solution. All right, and the final problem here has the case where I do need to simplify this using the distributive property. So I'll go ahead and distribute this 2x to each side, to both the x and the 5. When I do that, I get a 2x squared plus 10x, and then I have plus 3. Over on the other side, I'm going to simplify by combining the 4x and the 5x. So that will give me 9x when I combine those, and then plus 2x squared, and then plus 10. And we can see that both on the left and right hand side, they both contain 2x squared. So I'm going to subtract a 2x squared from each side, minus 2x squared. That'll give me some zeros on the left and right. So now I'm going to have 10x plus 3 equals 9x plus 10. I think I'll choose to take away 9x. The beauty of this is, you know, as long as you're following these properties of equality, there's lots of ways you can get there. I'm just choosing to subtract 9x from each side. Over on the left-hand side, I have just a single x plus 3, and that equals 10. And then to solve, I'm just going to remove 3 from both sides of that, and that tells me that x should be the number 7. So let's come back up here and verify that x is 7 with the original problem, and that's quite long. Let me see if I can make enough room for it so we can see that on the screen there. So I'll clear my calculator, and I'm going to go ahead and go 2 times 7 times open parentheses 7 plus 5. So that's 2 times x times the quantity of x plus 5, close parentheses, plus 3. And I can see on that one side it gave me 171. I'm looking for the same value over on the right hand side. So we're going to hit 4 times 7. That's what we think x is. Plus 2 times 7 squared. So we're squaring the 7. And then I'm going to have a plus 5x. So 5 times 7. And then finally plus the number 10. So I've got 4 times x plus 2 times x squared plus 5 times x plus 10. And when I press enter, you can see it also gives me 171. So this is the verified solution to the equation, right? X definitely is the value 7. And when x is 7, it makes both the left and the right hand side of this equality statement equal 171. So it makes it true. That's it for question, geez, what question was this? Question 6.